operations for Chapter 8. So, Chapter 8 summary. So, here are some of the things that we learned about in Chapter 7. Some of the things in Chapter 7 will go over more in depth in Chapter 8. In Chapter 7, we introduced the idea of types as a way to organize values and objects manipulated by CS programs. Here in Chapter 8, we will begin to cover one of the more important types of constructors, which are records, arrays, strings, sets, pointers, lists, and files. Records will also be broken down into two different types, variants and multiples. So a few things about records. Record types allow related data of heterogeneous types to be stored and manipulated together. These are also known as structs. But in Java, for example, classes are the only thing that represents a struct or a similar keyword. Everything else in Java is a class. C# and Swift use a reference model for variables of class types and a value model for variables of struct types. For example, here is a record. Here is an example of dot notation. Here we can see element is copper, constant ANN 6022E3, copper name is 0. As you can see here, the how this is defined with dot notation is that it's element type, and then it's the element name, as well as other things like this is element type, as well as or like the higher element type, and then this is element type, and then this is the element name, and then this is the value. Okay, in other languages, the syntax might look a little bit different here. For instance, we have struct or with char names, stuff like that. But for instance, in Fortran 90 and in Common Lisp, only the second alternative is permitted, as record fields can have record types, but declarations cannot be lexicographically nested. Declarations of different language records depend on the language. As noted in example 7.17, ML and its relatives differ from what most languages specifying the order of a record field is insignificant. The OCaml record value name equals CU, atomic number 29, atomic weight equals 63, italic true. It's the same value as if the atomic number was the same. OCaml's tuples, which we mentioned briefly in section 7.2.4, will visit in SML the other leading ML dialect. The resemblance is actually equivalence. Tuples are defined as syntactic sugar for records whose field names are small integers. The value CU29 1 equals CU 2 equals 29 and 2 equals 29 1 CU will all test true for equality in SML. Jeez, fuck, that was bad.